This video is regarding transmission parameters or ABCD parameters. Here, the input port voltage and current, that is V1 and I1, are expressed as functions of output port parameters, output port voltages V2 and I2 minus I2. So, in ABCD parameters, V1 I1 are expressed as functions of V2 and minus I2. These are the expressions. V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. One thing to be noted is that this negative sign is with I2. It is not with the parameter B and D. The negative sign is the negative sign with I2. Both the equations are written in matrix form. And from this equation, we can write A is equal to V1 by V2 provided I2 is 0. Similarly, C can be written as I1 by V2 provided I2 is 0. And the next parameter is B. And from the first equation, we can write B is equal to minus V1 divided by I2 when V2 is 0. Then D. From the second equation, we can write D is equal to minus I1 by I2 when V2 is equal to 0. The parameter A is the reverse voltage gain with output port open circuited, and C is the transfer admittance with output port open circuited, and B is the transfer impedance with the output port short circuited, and the last parameter D, which is minus I1 by I2, D is the reverse current gain with output port short circuited. Then condition for reciprocity. Let's consider the network. Here excitation is given at port 1 and response is measured from port 2. Short circuit current in port 2 is the response. And here excitation to response ratio will be Vs by I2 dash. Now our aim is to find out Vs divided by I2 dash. And from this diagram we can write input port voltage V1, that is voltage between these two terminals is V1 is equal to V2, is equal to Vs, source voltage Vs. And the output port voltage V2 is the potential between these two terminals is V2. And from this diagram it is clear that the two terminals are short circuited, hence the voltage V2 will be equal to 0. Then I1 is I1, then about I2. From this diagram it is clear that the second port current I2 is minus I2 dash. And these two are the ABCD parameter equations. Now apply the values to first equation. First equation is V1 is equal to AV2 minus BI2. Here V1 is Vs. So Vs is equal to V2 is 0. So that term got eliminated. Then B into I2 is minus I2 dash. So the first equation changed to Vs is equal to B into I2 dash. Now we can write Vs by I2 dash, which is the excitation to response ratio is B. Now let's consider the second case where position of excitation and response are interchanged like this. Now from this diagram it is clear that voltage at port 2, voltage between these two terminals is Vs. Voltage at port 1, voltage between these two terminals, here we are having a short circuit, so V1 is equal to 0. Then from the diagram it is clear that I1 is minus I1 dash. In this case also we have to find out the ratio of excitation to response. That is, here we have to calculate Vs divided by I1 dash. For that, let's consider the parameter equations and substitute values in the first parameter equation. So the first equation will change to 0 equal to AVs minus BI2. V2 is Vs and V1 is 0 here. Now let's consider the second equation. which gives minus I1 dash is equal to C into Vs minus D into I2. Now from the first equation we can write the value for I2 as I2 is equal to A by B Vs. And from this equation we can write minus I1 dash is equal to CVS minus D into I2 is replaced by A by B Vs. So now we can write the excitation to response ratio, which is Vs by I1 dash is equal to minus 1 divided by C minus AD by B. That is equal to B minus AD minus, B by AD minus BC. So in the second case, excitation to response ratio is B divided by AD minus BC. Now for this Q to be reciprocal, excitation to response ratio in first case should be same as excitation to response ratio in the second case. That means B should be equal to B divided by AD minus BC. From here we can write AD minus BC is equal to 1. This is the condition for the network to be reciprocal. Now condition for symmetry. When the output port is short circuited, that means when I2 is 0, from the parameter equations we will get the expressions like this. Vs is equal to AV2. Second term in terms of I2 is eliminated. And the second equation I1 is equal to CV2. Now Vs divided by I1 is A by C. When the output port is open circuited, that means I1 is equal to 0. From the parameter equation, we will get the relation 0 is equal to CVS minus DI2, or Vs by I2 is equal to D by C. Now for the network to be reciprocal, Vs divided by I1 when I2 is 0 should be same as Vs by I2 when I1 is 0. Then we will get the relation as A by C should be equal to D by C. That means A should be equal to D. This is the condition for the network to be symmetrical. Now let's move to a problem. Let's consider a network. Here we have to find out the transmission parameters. The transmission parameter equations are like this. V1 is equal to AV2 minus BI2. Second equation is I1 is equal to CV2 minus DI2. Now I have redrawn this circuit and marked the mesh currents. Now apply KVL to the first mesh. From first mesh we can write the equation V1 is equal to 5 plus 1, which is 6. So V1 is equal to 6I1 plus 5I2. Through the 5 ohm resistor, both currents I1 and I2 are flowing in same direction. So it is 5I2. Now apply KVL to the second mesh. Then we will get the equation as V2 is equal to 5I1 plus 7I2. So here we have the expression V1 is equal to 6I1 plus 5I2. But the parameter equation is like this. V1 is equal to AV2 minus BI2. That means we have to express V1 in terms of V2 and I2. But here we are having V1 in terms of I1 and I2. So it will be good if we can eliminate I1 and replace this term I1 with, or replace this term I1 in terms of V2 and I2. For that we will get or consider the second equation. From this equation number 2, we will get the value for I1 in terms of V2 and I2. So from here we can write 5I1 is equal to V2 minus 7I2, or I1 is equal to 1 by 5 V2 minus 7 by 5 I2. The next step is to substitute this value of I1 in equation number 1. So the equation already got is I1 is equal to 1 by 5 V2 minus 7 by 5 I2, which is in the same format with this equation, with the second equation. So mark it as equation A. Then go ahead, substitute the value of I1 in equation number 1. Then we will get the equation v1 is equal to 6 by 5 v2 minus 17 by 5 I2. Mark it as equation number B. Now we go to equations A and B in the same format with the parameter equations. Now we can compare this equation A and B with the parameter equations. Then we will get ABCD parameter for the given network as 6 by 5, 17 by 5, 1 by 5 and 7 by 5. These are the parameter equations. Now some more problems are there. Go refer the PDF, then refer the textbooks and do more problems. Okay, thank you.